This is part B, question 10 of the Seoul National University's mathematics aptitude test held in 2021, February 20th. This question is a really good question for students who study calculus and IB AHL mathematics. And this is a really good connection to topic 2 functions as well. This really requires the understanding of obviously calculus itself, but mostly the inverse function. So, for a function fx equals sine x plus pi x, the inverse function can be written as f of inverse x, and we want to find the definite integral from 0 to pi squared of the inverse function. Yeah. So if you are a normal mathematics AHL student, first thing you might have wanted to do is find the inverse, which is a totally normal thing to do. So we have y equals sine x plus pi x, and we want to find x equals f of y, right? So you try to change the x's and y's, simplify it, factorize it, do whatever, but you'll see that because it's connected by an additive function, let's say, it will not work. You cannot find a inverse function like this. So we have to find another method in which we can find the area under the curve of the inverse function from 0 to pi squared. So how can we do that is our question. Let's first draw a diagram. I think the diagram will help out a lot here. So if we drew a graph of f of x, we know that it's sine x plus pi x, so we know that it's a increasing function from, it's an increasing function, something like this, right? Yeah. And we want to find, this is fx. I don't really care about the shape. I mean, not the shape, but the exact stretch of the graph itself. More of how we're going to approach the question. So if we wanted to draw the inverse function, well, that would be a reflection of y to the graph y equals x. So that would be something like this, right? So this is the inverse. So this is f of inverse of x, right? And I want to find some point where I want to find the area from 0 to pi squared, which I don't know. Let's say this is pi squared. I want to find this area under the blue curve, right? This area. So now we think, how would we relate that with our original function, f of x? Well, there are a few ways you can think of it. You can firstly find the whole area under y of x. I'll draw that in green, actually. You can find this area, and then you can multiply it by 2, and then subtract it from the area under the curve from f of x. But that is more of a difficult approach, if you ask me. So here's my approach. This is f of inverse of x. We want to find the area from 0 to pi squared. Now, so we want to find this area under the curve. But we can find out that this area under the curve is from some place C. This is our goal. But we can actually find this area. So our goal is equal to the rectangle, which is this rectangle's area, which is C times pi squared, minus the area of the yellow. But what is the area of the yellow, you might ask? Well, that is the area of the yellow is just the integral from 0 to c of f of x dx, right? Because if we flip the y and x as an axis, then that is the sole definition of what an inverse function is, changing the input and output of a system, right? So what is this c? Well, that c is, that asking that c is the same thing as, what do you have to input into f of x to get pi squared, right? Because this is this coordinate over here on the f inverse of x is pi squared comma c, right? So that means f of the inverse of x of pi squared is equal to c, which is the same, but we don't know the inverse, so we can do the same thing as say pi squared is equal to f of c. So what do we have to input into our original function f of x to get pi squared as an answer? Well, here it's a bit obvious. X must be, c must be pi, right? Because sine of pi is 0, and x pi times pi equals pi squared. So c we found out to be pi. So we want to find now 0 to 0, the integral of 0 to pi of fx ds, which is the yellow area. So our original area, so the integral of pi squared of f of inverse of x dx just equals to the area of the rectangle, which is base times height, pi squared times pi, minus the integral of 0 to pi of fx of dx, right? So that's just pi cubed minus integral of 0 to pi of fx, which is sine x, minus pi x dx, right? Which is equal to pi cubed minus integral of sine x is minus cosine of x, minus cosine of x. Integral of minus pi x equals is equal to minus pi x squared over 2, right? Well, oh, sorry, it's plus pi x, right? In the question, yes. So this is plus pi x squared over 2, because pi is just a constant, it's just a number from 0 to pi, right? So this is pi cubed minus minus cosine of pi plus pi cubed over 2 minus cosine of 0 plus 0, right? This is pi cubed minus, the left part is cosine of pi equals minus 1, so that's just, cosine of pi equals minus 1, so that's pi cubed over 2 plus 1, and cosine of 0 is 1, so this is plus 1, so that's plus 2, right? Plus 1. So this is basically pi cubed minus pi cubed over 2 minus 2. Therefore, this is just pi cubed over 2 minus 2. And this is the answer for the area of under the curve of a inverse function. So if you need to find the area under the curve of a inverse function, and you cannot find the inverse, please try and think outside the box and think about functions in terms of functions in order to make the question easier for you to calculate. Thank you.